Hi, grade 11. So today we're going to be doing lesson 5.3 and 5.4, which is evaluating trigonometric ratios for angles between 0 and 360. So there's a handout on Teams that you should print and fill in as you watch this video. So getting started, at the top of your handout there it says, so far we've only considered trigonometric ratios within right angles, where each angle is less than 90 degrees. However, you can create triangles on the Cartesian plane, which is like a coordinate grid, using angles from 0 to 360 degrees by using the related acute angle. So, before we get started with the material on the handout, I just want you to find a little empty space on your paper and just draw this. So this is just the Cartesian plane, the coordinate grid. And before we get started, there's just a couple of things I want you to know. So there's 4 quadrants on the Cartesian plane, and we start in the positive quadrant. This is quadrant 1. We move counterclockwise to quadrant 2, down to quadrant 3, and back to quadrant 4. Okay, so that's important. We're going to be using those a lot in the next little while, and you're going to memorize that. The first quadrant deals with angles from 0 to 90 degrees. The second quadrant is angles that are between 90 and 180. The third quadrant is angles between 180 and 270. And the fourth quadrant is angles between 270 and 360. All right? So, there under terms, it says angles in standard form. And there's axis there. And we're just going to draw on the x-axis a line with an arrow. Then we're going to draw a diagonal line. And we're going to talk about this angle between those two. So this line here on the x-axis is called the initial arm. And whenever we talk about angles on a Cartesian plane, we always start here on the positive x-axis. And that's the initial arm. That's where we begin. This other arm is called the terminal arm. So the initial arm is where the angle begins, and the terminal arm is where the angle ends. The angle between the initial arm and the terminal arm, this angle here, is called the principal angle. And this principal angle is usually referred to as theta, angle theta. All right, the next little Cartesian plane there is called positive angles. So if I have 140 degrees, and I said draw this on a Cartesian plane, you'd start at the initial arm, and it would be somewhere over here. And this angle here would be 140 degrees. Theta equals 140 degrees. So positive angles are measured in a counterclockwise direction from the positive x-axis. All right? Okay, and then along with that, so that's our principal angle, 140 degrees. There's also something called the related acute angle, and that is this angle here. And we're going to call that angle beta, which is what it's usually referred to in the textbook. So beta is the related acute angle. And it's the angle between the terminal arm, so that's the arm where the angle ended, and the nearest x-axis. So there's only ever a related acute angle in quadrant 2, 3, and 4, because this angle here in quadrant 1 would be the principal angle, right? Because that's the nearest x-axis. So that's the related acute angle. It's kind of messy here, but it says the angle between the terminal arm and the nearest x-axis. All right, and then the last term is negative angles. So another Cartesian plane. If I have this angle over here, and it was angle negative 210, that's because this occurs when, this negative angle occurs when you measure clockwise from the positive x-axis. All right, so you start at the positive x-axis again, but now you're going clockwise, and that is a negative angle. All right, so those are some terms. Now let's move on to the following example. Create a triangle using the point 2, negative 4, and then find the principal angle using the 3 primary trig ratios. So on your grid here, just get one up, I'm going to plot the point 2, negative 4. So that's right there. If this is 2 and this is negative 4, then I'm going to create a triangle. So a couple notes about this. We always create the triangle from the x-axis. So that means that I start at the vertex here, draw that line down, and then I create this into a triangle by connecting it to the x-axis. All right? So this here is 2 units. This is negative 4 because we went down 4 on the y-axis. And then we still have to find this here. And this hypotenuse we refer to as the radius on a coordinate plane. And that's because how they find this radius is by creating a circle and then anywhere along this circle is going to be the radius, which is the distance from the origin to this point. And if you remember from grade 10, the distance, or the equation to find the radius of a circle is r equals the square root of x squared plus y squared. It's essentially the Pythagorean theorem. So we're going to calculate this radius, the hypotenuse now, by using r equals the square root of 2 squared plus negative 4 squared equals the square root of 4 plus 16 equals the square root of 20. Now let's simplify that a little bit. Remember when we learned about radicals? Whenever we had a radical that wasn't a perfect square, we tried to simplify it by breaking it down into something that had a perfect square. So root 20 can be broken down into root 4 times root 5. Root 4 is the same as 2 times root 5. So this radius here is 2 root 5. Okay, so now I have my length of my triangle. And I'm just going to get rid of this circle here because we don't need it. That's a 4. Now, I need to find the 3 primary trig ratios. So I want to find the principal angle. So remember that the principal angle, I start from the x-axis and then I go counterclockwise until I reach my line. Okay, so this is the angle I'm looking for. But I have this triangle over here. So I can find this angle theta using this angle here, which would be the related acute angle, which is angle beta. So I'm going to find angle beta, and then I'll use it to find theta. So to find angle beta here, I'm going to use the 3 primary trig ratios. So sine beta, cos beta, and tan beta. So sine, if you remember, is opposite over hypotenuse. So on this triangle, the side that is opposite beta would be -4. And the hypotenuse is the radius here, which is 2√5. Now I can simplify that because -4 over 2 is the same as -2 over 1. So that leaves me with -2√5. So sine beta equals -2√5. Cos beta is adjacent over hypotenuse. So adjacent is 2 over the hypotenuse is 2√5. Now 2 divided by 2 is 1. So this is just 1 over √5. Tan beta is opposite over adjacent. So -4 over 2, which is -2. All right, so those are the three primary trig ratios for this triangle. I can use any of those three to find angle beta. So in this case, I'm just going to pick sine. I'm going to use sine beta equals -2 over √5. Now I need to solve for angle beta, so I'm going to use the inverse. So beta equals sine inverse of -2 over √5. So you're going to grab your calculator and punch in sine inverse bracket -2 divided by √5. If you're using your phone calculator, you will want to first, or on an iPhone anyways, you'll want to first put in brackets -2 divided by √5 and then hit second and then sine inverse. And then it should come up. And the angle that you get here is -63.43 degrees. So this angle here is -63.43 degrees. Now, it seems weird that it's negative, but that's because it's being measured from the x-axis down. So as soon as you see negative in an angle, you know that they started here and they went that way. Now, I want to find theta here. So if this was -63, that means they just started here and this angle was 63. So beta itself equals 63.43 degrees. So a whole circle from here to here would be 360. But if beta is 63, I'm going to do 360 minus 63.43, and that will give me angle theta. So punch that into your calculator. 360 minus 63.43 equals 296.57. So therefore, the principal angle, angle theta, in this situation is 296.57 degrees. Right? Another thing to note is that R is always positive. So in your calculations, when we're using R later, just remember that it's always positive. All right, on to the second page. So, actually we do need this. So in general, if point x comma y, so if the point equals x comma y, and the radius equals the square root of x squared plus y squared, then the cast rule can be used to summarize which ratios will be positive or negative in each quadrant. Right? So this is something called the cast rule, and I'm going to show it to you now. So draw a coordinate grid on your paper there, just in the space, and then we're going to label the 4 quadrants. So like I said before, this is quadrant 1, then over to quadrant 2, quadrant 3, and quadrant 4. Quadrant 1 was 0 to 90 degrees. Quadrant 2 was 90 to 180. Quadrant 3 was 180 to 270. And quadrant 4 was 270 to 360. Now, the cast rule. Quadrant 4 is letter C. Quadrant 1 is letter A. Quadrant 2 is letter S. And quadrant 3 is letter T. So, as you can see, I spelled the word cast, C-A-S-T. Now, this is going to help us remember what is positive in which quadrant. All right? So, my coordinates in quadrant 1, x would be positive and y would be positive. My coordinates in quadrant 2, x is negative because we're going this way, and y is still positive. Quadrant 3, they're both negative, and quadrant 4, x is positive and y is negative. Now, as you might have guessed, these letters represent something. So A stands for all, meaning all the trig ratios are positive. S in quadrant 2 stands for sine, meaning sine is positive in quadrant 2. T in quadrant 3 stands for tangent, meaning tangent is positive in quadrant 3. And C stands for cosine, meaning cosine is positive in quadrant 4. All right, so they're all positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. Okay, a couple more notes about this here. So for any triangle in any quadrant, the primary trig ratios will always involve the same side lengths. So sine theta will always be y over r. And that's because, so if I have my triangle here, and I'm looking at this angle here, y will be this side length here, which is the opposite, and r is the hypotenuse. Cos theta will be x over r. And that's because I'm looking at adjacent over hypotenuse. And tan theta will be y over x because I'm looking at opposite over adjacent. And then each ratio will be positive in 2 quadrants and negative in the other 2. All right, so now, how do we solve problems about this? So let's go to example 1. Given that cos theta equals negative 8 over 17, find any values of theta that produce this ratio for the domain of 0 to 360. So theta is between 0 and 360, and there's going to be 2 solutions actually. So we're going to look at our coordinate plane, and we're going to look at where is cos negative, because this number is negative. We need to say where is cos negative. So where is this going to happen that we end up with a ratio of negative 8 over 17? So cos is positive here because it's a C. The first quadrant, everything is positive. It's negative in quadrant 2 and it's negative in quadrant 3, which means that these angles are going to occur in quadrant 2 and 3. So there's going to be 2 answers. 2 different angles for theta are going to create this answer. And one is going to be in quadrant 2 and one is going to be in quadrant 3. So let's just write that out. So this is negative. Using cast, we know that cosine is negative. In quadrant 2 and quadrant 3. So we can create triangles that should say with the given side lengths there. So I have one here and one here. All right, so cos theta equals -8/17. So now, when I go to my calculator and I say theta equals cos inverse -8/17 and punch that in, cos inverse bracket -8 divided by 17 equals 118.1 degrees. All right, so 118.1. Quadrant 1 goes from 0 to 90, so it's bigger than that. So yes, it is in quadrant 2. So that means this angle here equals 118.1. But we know there's going to be another solution. So your calculator will just give you the one that's closest to 0. So it gave us the first solution. But we know there's another solution because cos is also negative in quadrant 3. So I want to measure it to this one here. So I'm going to measure 360 from here minus 118.1. Equals, punch that into your calculator, 241.9. Now, quadrant 3 goes from 180 to 270. So yeah, this number is in quadrant 3. So this one was in quadrant 2, great, and this one was in quadrant 3, great. So those are my two solutions for cos theta equals -8/17. Theta equals 118.1 and theta equals 241.9. If you plug into your calculator cos 241.9, you'll get -0.47, which is the same as -8 divided by 17. If you punch in cos 118.1, you'll also get -0.47. So see how you're getting the same answer for two different angles, and that's because there's two solutions for cos for this problem. All right, number 2. A. Determine the primary trig ratios for the following angles whose terminal arm is defined by this point, and also find the principal angle. So if the point is 2, 3, I know that's in the first quadrant, so I'm just going to draw that. I'm going to create a triangle with it. So this is 2 and this is 3, and I need to find this angle here. That's my principal angle. And I know that because it's in quadrant 1. So the first thing I need to do is find the hypotenuse or the radius. So I'm going to use radius equals the square root of x squared plus y squared equals the square root of 2 squared plus 3 squared equals the square root of 4 plus 9 equals the square root of 13. So this length here is the square root of 13. Now, to find this angle, first I need to say what the three primary trig ratios are. So sine theta, SOHCAHTOA, sine equals opposite over hypotenuse. So the opposite side of theta is 3, and the hypotenuse is root 13. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So that would be 3 over 2. Okay, so now I can use any one of these three trig ratios to find angle theta. So I'm just going to use tan because it looks the easiest with no root signs. So tan theta equals 3 over 2. So theta equals tan inverse 3 over 2. Punch that into my calculator, and I get 56.3. Now, I don't have to do any other calculations to find like 360 minus this or 180 minus this because it's in quadrant 1 because x and y are both positive. So that is my principal angle. All right, B. My point is -2, -5. So now I'm going -2, -5. Create my triangle. This is -2, and this is -5. Now we're going to find R. R equals the square root of -2 squared plus -5 squared equals the square root of 4 plus 25 equals the square root of 29. So this length here is the square root of 29. Now the three primary trig ratios would be, for this angle here, sine. Now I'm going to call this angle beta because I'm not starting at the x-axis here. Okay, so that would be theta if I started here and went all the way. But I'm only finding this little one here, which is beta. It's the related acute angle. So I'm going to find sine beta. So again, SOHCAHTOA. So opposite of beta is -5 over the hypotenuse is root 29. Cos beta is adjacent, which is -2 over hypotenuse, which is root 29. And tan beta is opposite, which is -5 over adjacent, which is -2. Now those negative signs would cancel out, so 5 over 2. Now that makes sense because I'm in quadrant 3 here, and in quadrant 3, let's go back and look, here, tan is going to be positive. Of my 3 trig ratios, tan is the only one that's positive, and that makes sense. So I want to solve for angle beta, so I'm going to use tan here. It seems like the simplest solution. So tan beta equals 5 over 2. So beta equals tan inverse 5 over 2. Punch that into your calculator, and that equals 68.2. Now, that's this little angle here. But I want to find the principal angle. So that means I'm starting at the positive x-axis and I'm going all the way to my terminal arm. So this line here would be 180 degrees. So now I'm doing 180 degrees plus beta, which is 180 degrees plus 68.2, which is 248.2 degrees. So that's angle theta, my principal angle. All right, hopefully that makes sense. Let me know if you have any questions. And if you are still confused, take a look in your textbook at the beginning of lesson 5.3 and 5.4. There's some more explanations of this. And also, if you still need help, let me know and I can recommend some more YouTube videos for you to watch. Have a good day.